Hi, this is Marv again with the fourth video for this course. Again, we're about a fourth of the way through the course. And I'm just going to say a couple of things at this time before we go into the material for today. I know it's difficult. I know this is summertime. I know you're working hours. I know you have your own personal schedule. But I really feel as though that with stats, it's something we want to review on a daily basis. Maybe we don't want to review it on a daily basis. Maybe we just like to get away from it for a week. But if a person studies a concept in stats, and then you don't come back to it for about a week, sometimes that concept can be lost. And so, as frequently as you can, whatever your schedule allows you to do. I'm not talking about your water skiing and hiking schedule, but whatever your schedule allows you to do. Review stats, keep that fresh in mind. That's part of the process of learning the material. Now, today we're going to talk about a couple of concepts, and I might add this too. That if you have any questions about stats, send me an email, put it in chat room, put it in forums, go ahead and ask. I don't care what the question is. Just go ahead and ask whatever question you would like. Now today, we're going to be looking at stem and leaf, discrete and continuous data. Two important concepts in stats is the mean and the normal curve, and then we're going to be looking at standard deviation. Now, given these then, we're going to take a look at the normal curve to begin with. Well, I'm going to go with the stem and leaf. First of all, we have the stem and leaf that was given to you, and this is the way the diagram was drawn here. Then we had the stem, and we had the leaf. Now, Smith did an excellent job on this. There's no problem. But there was a couple of concepts that I wanted to go over. Supposing we have the three numbers such as this, such as 5, 82, and we'll put down 126. These are the three numbers. We have a one-digit number, a two-digit number, and a three-digit number. Well, if we have a 5, remember that the first part, like in 82, the 8 would go under the stem, and the 2 would go under the leaf. But what if we have 5? Well, if we have 5, we would put a 0 here, and we would put a 5 here. Okay? That's the stem and leaf for 5. Now, if we have 82, we would put the 8 here, and we would put the 2 right here. Well, what about 126? Well, if we have 126, we would put 1, 2 here, and then we would put the 6 over here for the leaf part. Now, if you notice that what goes under the leaf is in the ones place. I'm going to put this right here. It's in the ones place. Now the ones place for 5, of course, it's 5. The ones place for 2, or for 82, is 2. And of course the 8 is in the tens place. The ones place for 126 is the 6. And then the 2 would be in the tens place, and the 1 would be in the hundreds place. And so down here on this side for the leaf, we just put the ones place. If we had 271, we would write down 27 and then 1 here. So again, it's just the ones place. Okay, now what I wanted to visit with you about is the normal curve. Now, probably when I get done drawing it, it won't look so normal. But anyway, I'm going to go ahead and start out. The normal curve we have here. Then we have our line under it. Now you'll notice that, at least it shouldn't, that the ends never close, and that allows for extreme measurement. And extreme measurement is another way of saying outlier. An outlier. If we were going to take the measurement of individuals, and we take 48 inches and 63 inches and 65 inches, 42 inches, and then we would measure someone that would be 80 inches. That 80 inches would be the outlier. So an outlier is an extreme measurement, and we leave the ends open to allow for that outlier. Now what we have here, we have some concepts in here, and I'm going to draw some different types of curves. What we have here, to begin with, down the center of a normal curve, we have the mean, and we have the median. This is on a normal curve, and we have the mode. All on a normal curve. They all have the same value. All right, now, I don't want to confuse anyone about the normal curve, and I may come on again with some more material about the normal curve. I wanted to show you here, if we have a curve, this is a normal curve. If we have a curve that would appear like this, very high, we would call that a leptokurtic curve. Okay, and the reason for that is because the numbers are somewhat bunched together, pushing the middle up higher. Then, now this is lepto, you can associate lepto with leap and lepto. But if we had a curve resembling this here, somewhat flatter, we would call that a platykurtic curve. Platykurtic rhymes with flat. So of the three curves then, we have the normal curve, we have the lepto, meaning leap. I don't know whether it means leap, but that's the way I remember it. And then we have the platykurtic curve. Now, there are some more aspects here with the curve. Now remember, we have the mean and the median and the mode all right down the center. We can have a curve like this, and we call this skewness, where the bulk of the numbers are down at the bottom part of the curve, and then there's a few up here. This is skewness. All right. This here is positively skewed because the tail goes this way. Now, if a test was given and individuals did very well on the test, and they received a lot of high scores here, which is okay. This here is negatively skewed. Remember that the skewness goes with the tail. Okay. Now, another aspect that we were going to be looking at was continuous and discrete data. Continuous data usually involves some type of numbers, and they continue on. Like we talked about the wage earner. One person making $15.01, another person making $17.50. In other words, they continue on. With a discrete data, we have just a type or a name. Now we have different types of data. If we were going to look at the different cars and we saw so many Chevys and so many Fords and so many Dodges, that would be discrete data because it is just a name by itself. This here we want to remember on this continuous data right here. See if I can get this up just a little bit here for you so you can see it. I will just go over here. On this, here, okay. On this data here, we were talking about the continuous and the discrete data. And I want to call this to your attention on the Smith videos. On the continuous data, we have numbers, and on the discrete data, we have types or names. What was interesting is, on the Smith video, she had siblings there, and she put the siblings on a histogram. Well, that may have been correct. I'm not quite sure where she was coming from. But if you notice, she put the siblings on a histogram. Well, I feel as though it probably would have worked out better if it would have been on a bar graph, because it's not really continuous data. You can't have 1 1/3 siblings. You can have one sibling or you can have two siblings, but you cannot have 1 1/3. So this just kind of helps us, or we'll say 2 1/2 siblings. You can't have that. Or 3/4 of a sibling. Where this here will work on a histogram, the siblings work better because they are not continuous data. The siblings would probably work better on a bar graph. Okay, again, that covers the material that we have for today on this. I just wanted an understanding of the normal curve and the standard deviation. I'm going to be talking to you about the standard deviation a little bit later on. The standard deviation is an important aspect of what we are doing, but this just about takes all of our time for this video. So you can go through this and kind of get this in your mind. This is just for you to get in your mind. And if you have any questions, doesn't make any difference what the question is, about stats. I'm assuming that all is going well because I really haven't had any questions about stats. And if you have any questions, I will be more than happy to respond to you and discuss them with you. So until the next video, which I will probably visit a little bit more about standard deviation, you have a good day.